While solid colors can serve as the foundation of 3D rendering in WebGPU, color maps unlock a whole new level of visual storytelling and depth. Color maps add texture, highlight features, aid data visualization, and allow for artistic expression. They differentiate object components, improve realism, and engage users with dynamic visual effects, making scenes more visually appealing and immersive. Hello everyone. Welcome to my YouTube channel, Practical Programming with Dr. Sue. In the examples presented in the previous videos, we always applied a single solid color to render 3D objects in the PyGFX rendering engine. While solid colors serve a basic purpose, color maps can enhance 3D rendering by introducing varied colors based on object attributes. For instance, color maps excel at representing data associated with 3D objects. Image a heat map on a 3D terrain where the color gradient visually encodes temperature variations. This immediately conveys information to the viewer without needing additional text or overlays. Color maps can simulate real-world material properties like metallic sheen or iridescence. By mapping a color map to a roughness or normal map, you can create objects that shimmer and change color as they move and interact with light. Color maps are not restricted to data or realism. They can be used purely for artistic expression, creating vibrant and eye-catching visuals. Imagine using a psychedelic color map on a low-poly object or a watercolor-style map on a fluid simulation. Mimicking real-world materials and lighting conditions becomes more achievable with color maps. By using color variations based on physical properties such as reflection, refraction, and absorption, you can create more realistic and immersive 3D environments. Color maps offer versatility and power in conveying information and enhancing the overall aesthetic in computer graphics. Today, we'll explore how to create color maps and how to use them to render 3D objects in the PyGFX engine. Actually, color maps are simply tables or lists of colors organized in a desired fashion. The objects can be associated with a color map by generating an M/3 color matrix. Each row of this matrix represents RGB values. For example, if you want to use a color map to represent the Y values of a 3D surface plot, you can use the data range of Y minimum and Y maximum to linearly transform the Y data values to indices where each index identifies an RGB row or a color in the color map matrix. The mathematical transformation of the color index values can be described using this formula. Here Y is the individual value of the Y data and M is the length of the color map matrix. This formula allows you to use the entire range of colors in the color map over the plotted data. Here shows the surface plot of the sync function using the color map described in this formula. It is easy to create your own custom color map using simple mathematical formula. Here, I provide a few commonly used color maps created using various M/3 color map arrays. We can place these custom color maps into a separate file called colormapdata.py in the common folder. Here is the code for these color maps. Inside this data function, each color map contains 11 RGB color arrays and has a standard color map name. Some of the commonly used color map names can be represented using a color map strip, as shown here. The color map names such as jet, hot, cool, rainbow, etc. are often used in computer graphics. In the same way, you can add your own color maps to this file and use them to map the colors for 3D objects in your applications. Additionally, we create a dictionary called dict in this file, which allows you to easily select a color map using a numeric value. In the following, we'll use the color map as a 2D texture, which will be mapped onto 3D objects. To achieve this, we need to use the texture or UV coordinates, as shown here. In most graphics engines, including PyGFX, the texture coordinates are a way to map 2D image textures onto 3D surfaces. These coordinates are essential for specifying how textures should be wrapped around or applied to geometric objects. In fact, the texture coordinates are a pair of UV values associated with each vertex of a 3D object. The UV values range typically from 0 to 1, representing the horizontal and vertical positions within the texture images. When rendering a 3D scene, we use the UV coordinates to map points on a geometric surface to corresponding points on a 2D texture. We can also manipulate the UV coordinates in various ways. For instance, Procedural textures or UV mapping tools can be used to apply textures in creative ways. In this video, we simply use the color map as a 2D texture, mapping it onto 3D objects. To achieve this, we'll implement a common function in the helper.py file. Open this file from the common folder and add a new function called createColorMapTexture. Here is the code for this function. It takes ColorMap name as input argument and uses it to retrieve the ColorMap data from ColorMap data file. This function then converts the ColorMap data into a number py array of type float, 32. Subsequently, it concatenates the ColorMap array with its vertically flipped version along the vertical axis. This concatenation is done to ensure a smooth transition between the beginning and end of the color map. Next, the code creates a texture object using the GFXTexture function. It uses the color map array as the texture data and specifies that the texture is one-dimensional. Finally, the createColorMapTexture function returns the created texture object. Now, we are ready to add color map to 3D objects. First, import relevant modules, including PyGFX engine and Python linear algebra library. We then using the system path to import our helper module. Next, we define a color map direction. Here 0 represents the U direction, while 1 represents the V direction in the texture coordinate system. Subsequently, in this code snippet, we create a climb bottle geometry with a scaling factor of 2. We then modify the texture coordinates of the geometry to use only the specified color map direction. Next, we call createColorMapTexture using the getColorMap by calling the createColorMapTexture function implemented previously in the helper module. Moreover, we create a Phong material for the mesh and assign the color map texture to it. Next, we create the climb bottle object with the geometry and the material. Next, we define an animate function to rotate the object continuously, and finally, we call the GFXShow function to display the climb bottle on the screen. You can observe the climb bottle with color map, which looks more appealing than with a single solid color. You can also easily create a different object with the color map by altering the climb bottle geometry to a torus knot geometry. At the same time, we'll change the jet color map to the cool color map. This gives the torus knot object with a different color map as shown on the screen. To seamlessly change the color map, we'll incorporate the keyboard interaction into the code. To achieve this, here, we first need to import the keyboard module, as well as the color map data file located in the common directory. Then, we define the U data and V data from geometry's texture coordinate data and reassign the U data to the geometry's texture coordinates attribute. Subsequently, we define two variables, color map type and space pressed. The color map type is an integer variable representing the numeric key in the color map dictionary defined in the colormapdata.py file. This numeric key can be used to select different color maps. While space pressed is a Boolean variable that is used to check whether the space key is pressed or not. Inside the animate function, we need to declare color map type and space pressed as global variables. Next, we add this code snippet to the animate function. Here, we first check if the space key is pressed. If yes, the color map type increments by 1 and ensures it wraps around to 0 when it reaches 17. This is used to cycle through all color map types. For a new color map type, we create a new color map texture by calling the createColorMapTexture function defined in the helper module. We then update the color map texture of the material associated with the 3D object to the newly created texture. The space pressed variable is merely used to track whether the space key was pressed in the previous frame to ensure that the code block inside the if statement is executed only once when the space key is initially pressed down. In summary, this code snippet allows for the dynamic switching of color maps by pressing the space key. It cycles through different color map types, updates the color map texture of the 3D object, and prints the current color map name to the console. The use of the space pressed variable ensures that the color map switch only happens once per press. Running this code produces the torus knot object with the cool color map. Now, press the space key will change to a new color map whose name will be printed in the terminal window. We can do the same thing for the color map direction. Now, define a new Boolean variable named altPressed and declare it in color map direction as global variables inside the animate function. Next, add the following code snippet. This code allows for toggling between two sets of textures, UData and VData, for a 3D object by pressing the Alt key. The direction of texture coordinates is determined by the value of color map direction variable, which is toggled between 0 and 1. The use of Alt pressed ensures that the toggle happens only once per press of the Alt key. Running this code produces the torus knot object with the cool color map. Now, you can not only change the color map by pressing the space key, but also alter the color map direction by pressing the Alt key. You can observe the color map changes direction when pressing the Alt key. Of course, we can change the geometry to a Klein bottle and change the default color map back to a jet. This code generates a Klein bottle on the screen. You can change the color maps by pressing the space key. You can also change the color map direction by pressing the Alt key. You may notice an issue associated with the Klein bottle when VData texture is used by pressing the Alt key. The small handle seems out of phase by 180 degrees. We hope that the issue associated with this built-in Klein bottle geometry can be fixed in a new release of the PyGFX rendering engine. Now is our showcase time. We'll place 3D objects with color maps to different CubeMap skybox environments. Here are some examples, which demonstrate a more appealing visual effect is generated with the color map.